Okay, all right, so we're graphing square root function, okay? So last time we sketched reciprocal function. So basically, we're going to sketch or start with this parabola. As usual, from here, the y-intercept is -1, and the x-intercept, if I factorize that, is this. So we've got the following points to start off with. So let's label them up. So 1, 1, -1. That's nice. So we've got 1, -1, and -1. And since I've got 1s, I'll just put 1 up here as well. And just to be, safe and do some extra work, I'll put some extra points. So 2, -2, and 2. And like I said, another useful point that you want to play around with is half. All right. So -1, 1 and -1. Is that on? Yep. So got -1, 1 and -1. If I make any silly mistakes, let me know, because especially in the morning when I'm teaching, just like you girls, I could make a lot of silly mistakes because I'm not myself. So, all right, we're going to start off with this graph. Okay. From this graph, give me a second. Now they want us to sketch this, which I'll do it in purple as usual. So what they're basically asking to sketch now is sketch y equals to root of x squared -1. Okay, so that's what they want us to sketch. In order to do that, let's once again examine some y values like last time and see what the pattern is. So in this case, girls, let's have a look at 2. All right, so y equals to 2 on this graph is here to start off with. Okay, so from 2, in our question here, what are we doing to the 2? We are rooting the 2.
Wait, does that mean you have to write the asymptote?
Oh, no. We'll get to that. You will get to that. Okay? Now, root 2 in the calculator is 1.4. So at 2, it goes down to 1.4. So that's about there. So I'll put my first point there. Okay, that's my first point of the new graph. Okay? Let's try the next point for 1. So on the original graph, y equals to 1 is here, and on the original graph, it's here. And if you root 1, that's obviously 1. So it has to go through, once again, 1 like last time. Yep. Let's keep going just to see what general trend we get. All right, so if I root 0.5 in the calculator, it's actually 0.7, so you get a bigger number. So 0.5 on the original graph is here. And from there, it goes up to 0.7, so slightly just above, okay? Slightly just above 0.5. So 2 more points. At 0, if you square root 0, what's that? 0, yep. So remember, 0 is here, and on the graph, it's there. And because if you square root 0, you get the same value. And once again, it's going to go through 0. There's no change in that. Does that make sense so far?
Yes.
Now, however, if you get any negative values, can you square root negative?
No.
No, there is no answer. It's undefined, right? So that's the first fact. So that's a negative 0.5. You can't square root any negative numbers. That means you can't transform anything below the x-axis. So you completely ignore the graph below the x-axis part. Okay? Because you can't square root negative values. So that's your first rule when you square root a graph. You just completely neglect anything under the x-axis. So we've got that. If you look at that pattern and if you draw a curve, it actually looks like this if you continue. Okay? What you'll realize is the curve here is actually, as you can see, less steeper or under the original graph, which makes sense because as you get higher and higher value, let's say that point is 10. If you square root 10, you're going to get a smaller value than 10. Doesn't that make sense? Yeah? If it was 16, if you square root 16, what do you get? 4. Yeah? So basically, the same thing here. So the rules with a square root function, it has to go through 0 and it has to go through 1. Okay? And then after that, continue it, and then you just draw a curve less steeper than the original graph. And that's your answer for this. Okay, so like I said, I'll write a summary note for this. Okay? Yeah, so notes root of f of x. Now, I want you to keep in mind, and this is important, right now, we've learned how to sketch just plus root x. Next, the last example, I'm going to show you how to sketch both plus minus root f of x. Because you know how when you square root something, you always usually put plus or minus root something? Right now, all we've drawn is just a plus of root x. Okay, so notes for plus root x. That's your notes. I'll take a photo and I'll do the next two examples. And those two examples next should be enough for you to do the whole exercise.
Okay.
Oh, sorry, hold on. Just letting you know, and for the record, see that line? Yeah. You see how it looks different? It's not meant to be. That line is supposed to look exactly the same. Try to be as accurate. It's meant to be the same. It looks different now that I look at it. Yeah, it's just my morning sketching. They're meant to be the same looking on both sides, okay? All right, so we square rooted a parabola last example. We're square rooting a parabola again, but what's the difference between the previous one and this parabola? Yeah, it's going to be an upside down parabola just by looking at that. All right, so y-intercept is 4. X-intercept, instead of me factorizing it, can you tell me straight away what it will be?
-4.
Ah.
Are you stupid?
Because.
It's the morning.
All right, okay, I forgive you. Yeah. All right, so we got y equals to 4. So 1, 2, 3, 4. All right, and like I said, whatever points you put here, you also want to put it under here. -1, -2, -3, -4. 1, and I got -2, goes through 4. Okay, so it's going to look like this. Does it look somewhat symmetrical? Yeah, it's okay. It goes to that. All right. Okay. So, like I said, first thing, neglect my first stop point. Neglect all the graph under the x-axis because you can't square any negative numbers. So, just get rid of that. Second thing, it must go through 0 and 1 because, like I said, it's the same value. So, I always forget to label 0. So, 0 on the original graph you've got across is here and here. So, it has to go through those points. So see how from last lesson when we reciprocated, the x-intercepts or these points were asymptotes? Well, for square rooting it, it's not an asymptote anymore. It just goes, it has to go through that point. Same thing, 0 and 1. So 1 on the original graph is here, so it has to go through there as well as the other side. Okay? Now, it's not going to be always a curve like that. Okay? This one's different. And to know what it will look like, let's go through a few more values. Let's have a look at 4. So from 4, obviously if you square root that, that's 2. So from 4, it goes down to 2. So it actually has to go through here.
What?
So yeah, it's slightly different, right? Just to confirm, let's try 3 out. If you square root 3, is that 1.7 or 1.5? Yeah, 1.7, yeah. So at 3 on the graph is here. Okay, and then that's going to go down to 1.7. So 1.7, that's like just beneath 2. Yeah, 1.7 is like there. So it's going to go down here. And it's going to go down here. 1.7. Huh?
You said it's beneath 2.
Did I put it above 2? Yeah. That's not above 2. Okay.
That's kind of like 2.
All right. Is that all right? That's meant to be 1.7. 1.7. Yeah, it's enough. Yeah, that's fine. Yeah. So this time it actually looks like this. It's meant to actually be outside of the. Keep in mind, this is meant to be like outside of the original graph. It's not inside. It's actually outside. This part. Okay.
Why? It would hit the same points.
Oh no, because when you actually join these up, it's actually meant to be a curve, but it's a curve. If you actually link these dots up exactly and accurately, you'll find it's a curve that goes slightly outside of the original graph. Okay, so that's your answer. So the difference between what I did previously and this one, so when you have an upside down parabola and when you have an upright parabola, okay, so when you square in, this is a general fact again, if you square root a concave up parabola, it usually, like I said, the curves go outwards, but if you're square rooting like concave down parabola. It's actually like a circle. Or it's not exactly a circle, but that's what it looks like. Okay? Because the difference here is you're square rooting a number that goes infinitely up. Okay? Here, remember, when you're square rooting something, you're neglecting the bottom. You're square rooting a number that has a cap. Yeah? It's not like infinitely going up. So because you're square rooting something that's limited, that's what it looks like. When you square root a number or graph that goes infinitely up, it will just infinitely go just less steeper than the original graph, okay? So that's the difference. That's what I wanted to show you. So, girls, notice how in this question, it doesn't say square root of x. It says sketch y squared equals f of x. So when there's a square and you want to get rid of it, right? You know how you usually do plus or minus root of that? Yeah, just like how when you do, like if x squared is equal to like 4 and you want to solve that, then x is equal to plus or minus root 4, which is the answer is plus or minus 2, but we're just going up to here. Yeah, it's the same thing here. So you're responsible to actually know that you've got to sketch that, even if they don't explicitly say that.
Wait,
and
like, won't everything under 2 not matter anyway? So like...
Wait, hold on. But do you get that?
Yeah.
Yep. All right, so as usual, girls, let's sketch that. All right, so x equals 0 here. I'm just doing the x-intercepts first. Oh, why am I doing it in purple? It's the original graph. That's my x-intercept. Yeah, so y-intercept, like your girl said, is 0 because why? Explain that again. It made sense, but I don't know how to say it.
All the x's and times all the numbers other than x.
Because they're all times together. So
No, you make x 0.
Oh, yeah, that's right. Yeah, I've been teaching this all this time. If you want to find the y-intercept, you substitute x equals to 0, and then you'll get your y value. And the 0 times everything is 0. Okay, smart, thanks. I taught you girls well. Something that I forget. All right, so y-intercept is 0 if you substitute x equals 0. Good. So let's label these points. So it has to go through 0 in my original graph. It has to go through 1. It has to go through minus 3. 1, 2, 3. Okay, so those 3 points, and okay, so that's that. And it's going to look like this because the highest power of x cubed if expanded out is that. Yeah, remember that? Polynomials? Yep. All right, so let's draw this graph. Something like that, yep. All right, now, one thing that I need you girls to know is, you know how we don't know the peak, y value of that peak, okay? You can always assume the peak or the vertex of the peak is going to be more than 1. Okay? So this is the part where you just kind of assume 1 is there, just below the peak. Yep? Neglect all the graph under the x-axis. So let's just get rid of it. Or if you're doing it in pencil, you can just rub it out. Okay? Next point, it must go through 0 and 1. Okay. Right, it has to go through that. That's for 0. And it also has to go through 1. 1 is here. Go to where the graph is. It has to go through there. It has to go through there. And 1 is also at here. Is that like in line somewhat? Yeah, that's all right. Okay. So we've set up the first 2 points. Okay. Now, if you're not sure what the graph looks like, but like I said from last time, see how this is going infinitely up? So if you square root this part, from the previous example, if you draw a curve, what do? You just keep drawing the curve. That's the last step. Continue the curve less steeper than the original graph. That applies to the tail when it goes infinitely up. Yeah, using the previous example. However, with this bounded parabola, you know what it's going to look like from our just previous example? It's going to look like this. Okay? And which makes sense. Let's say, I have no idea, but let's say that was 4, right? If you square root 4, it's going to become like a smaller value underneath that peak. Yep, so that makes sense. So what I've just drawn, girls, is y equals to plus root f of x. Now, in order to draw, I wish I had another colored pen, and it's a simple fact. You know what, I'll just do it in purple. But if you also want to draw, I'll do it in black now. I'm going to get rid of this bottom part because, you know, that's what we ignored in the first place. If you want to draw the minus part now, all you now need to do is just reflect exactly what you've drawn at the bottom and just continue it like that, and that's your answer. So this part is y equals to minus root f of x, and this top part is your plus root f of x. And that's your answer. Okay? So that's all it is. So the extra step, and I'll put it in purple here, for y.
Yes.
Yeah? For every positive, yeah. Girls, just elaborate. Because plus 1, you're saying is also now minus 1. You're just reflecting over everything on top and bottom. All right? Nice and short. I'm going to stop here.